So when you put this in here, firstly you have to lift this up, you push this back, and then you slide it in. So that's one trouble you might have. You can remove this thing, but you shouldn't need to, but it may help. I think in this case it's easier. On my other old bike, this whole thing fell off when the thing didn't have this bolt in there, so it would just come off easily. You see, you've got 2 rings in there, at least 2, maybe more in there already. And now if you don't have those, that is going to eat into your frame, which you really don't want to happen. It did it a little bit on my mountain bike, but that was a steel frame with quite a thick dropout, so it's not such a problem. But you want to make sure there's enough. It comes with these rings, but some of them don't come with the rings, so you have to buy them. You've got different types of rings. I'm not really sure what the point of these ones is, to stop it rotating or something. See, it's not fully slid into. So, but the main problem you're going to have potentially is that to get those rings in, you're going to have to stretch the frame apart to get it to drop in once you've added the rings that you want. I stretched it a little bit. You don't really want to be stretching your frame too much. You don't want to use too much force, especially if it's an aluminum frame like this one. But can you see what's happening here is the rotor, the caliper here is rubbing against the motor. So this caliper here is coming out too wide, and it's rubbing against this. So what I probably have to do is add more rings into here to push this away. But that might mean that you're going to have to really stretch that frame to get that to drop in, which means it might not be a one-person job anymore to slide that hub motor in. This is one of the problems with this style of bike that you don't have with the mid-drive. Your other option is to buy a different brake, a different set of brakes, or a different rear brake that will have a different profile caliper. Now the problem you're going to have with that is, with this internal style of cable routing, you're going to have to dismantle your brakes to slide it through that middle of that thing. So it's not going to be just a simple case of swapping it over, unless you decide that you're going to route the brake along the bottom, along the outside of the thing, instead of along the inside. Basically ignoring the design of the bike and just running it along the outside instead. So the simplest solution is to make it slot into this. Now it may help for me to, what I'm going to try is remove one of these rings here to get it to go as close as possible on this side, and that will mean that the frame has to stretch less when I put a ring on this side. Does that make sense? Now the other problem to watch out for is this cable here. You want it to be as straight as possible. You want it to be as far away from the moving part as possible. So this thing should be on there. I haven't put it on yet. It may actually help to leave it off when you're trying to figure out these things in terms of whether it's going to fit. In this case you can see it doesn't fit, but when you're just trying to slot it in for the first time, it's actually helped not to have that on, because then I can see. But you can also see that this is where the rotor will go. You can see it doesn't perfectly align with where the brake pads are, so it needs to be modified anyway. Another thing you can do is unscrew this here, and sometimes they will slide a little bit this way, but there's a limit to how much it will do it. And if you are going to add a ring into here, then you may find that if you do that, the brake pad will no longer align correctly with the thing. Depending, you may not be able to achieve anything by trying to move this further away, because you may find if you have to add a ring in there, it will no longer line up. So yes, we may have big problems with this. Hopefully it will be simple. So we've had a look at this and made some more adjustments to it. For this one, I had to add a ring in here, add one ring here, and bend this round so that would fit. And then on this side I removed one ring. I removed one of the rings inside. It has two, I think it has two in there now, of these type. So with this it gives you many, but you won't need all of these. You don't need them all. It's going to depend on your bike and stuff. So that's good. So it is very close now. It is very, very close. But I don't think it's rubbing. Can you see? It might be rubbing slightly at some points in rotation, but I think it's okay. With this one, you got two choices. You can go this way, or you can flip the whole thing around and it can point that way. I don't think it really matters too much. I've had it either way. Having it this way means you can bend it more like this, whereas if you have it the other way, it's more likely to be straight, which might mean it rubs. But with these, it has this metal sheath on the edge, and that's actually really, really useful for protecting it. With the QS205, it does not have this metal sheath thing, and my cable was damaged on my other one, but not enough to break it. But it's a high powered bike, you probably want to install one or more of these, and these probably can go on the inside here, but it might not, the bolt might not go through. They can also go on the outside, I believe, so it's going to depend on how thick it is. This one's very thick. It's probably thicker than this washer, so it might be better on the outside, but the way the swing arm is, you have to think, is it actually going to fit in there or not? It's actually comes out further on this side than it does on this side, but hopefully there'll be just enough room to fit one on this side as well. on the end here, this is a standard connector for the hall sensors. This is a sort of low voltage electronic circuit. Now this is the 3-phase wires that delivers the motor power. So the hall sensor wires basically tell it which combination of these 3 wires the power needs to be delivered to. By it senses the motor's position. So you've got different loops of wires, different than a traditional brush motor. It has, I think it's 3 different loops of wire that sort of alternates, and they're called it's called pole pairs, I think. So this is like a quick disconnector connector. Some of them have a different type, where they have loops on the end and then you have to screw it into a plastic box. So I need to look at the other side of this that it corresponds to, and look and try and think how that's going to be able to connect to my controller basically. So now you've got your rotor in place, you've got your spacers in place, and you've decided where you want your cable to go. You've got your derailleur on, and you've checked that it's not wearing a hole in there. Now you wanna, what I did was I found that if I remove this, I'm gonna have a lot less of a problem. So what I can do is I can remove it, I can tuck it over this side, then when I have put this in place, I can try and put this back on, and hopefully, you know, it's going to be easier to do it that way rather than try to do it the other way. What I think I'm going to do now is use this hammer to just tap that into there. As you see, not all the way in. Now for your torque arm, this is what it looks like. You got 2 parts. You got this part, you got a bolt through the middle, and then you got a band thing, a metal band that goes through this slit here. So what we want to do, you've got multiple options, but what I would do probably is attach it around here like this, or like this, because what this is supposed to do is stop this from being able to fall out. So your motor wants to fall out this way, or wrench itself out by twisting sideways. So the torque arm sort of helps to alleviate both of those problems. So this here is not right. Firstly, we have too much slack, too much. On my other bike it went around, I think it went around a thicker part of it, and it didn't have this much slack to it. Secondly, that's no good there, because you want that to be flat, and this bolt has to put a lot of pressure onto this part. So this is no good. So this is how it should look. Like this. And on this side, like this. So connected it all up. Connected it all up just to test whether it's working. So what? It's a good idea to wear gloves. going to electrocute you if there's something wrong with it. Does that make sense? So you just turn it on. I've done this already. Right, here we go. So it needs charging up. It's around half, just a little bit over half. Watch. I'm just turning that slightly. Now what you that's making a weird noise. What you want to do before, what you're supposed to do before you use it, you can just do it a little bit like that, but before you actually use it properly, you want to run it. You have to connect it to the computer. You have to run it in something called test mode. You have to open up the software. It will show you all these parameters about the controller, and you want to run it in test mode, and basically it will sort of like keep spinning the motor like this by itself until it figures that it like diagnoses and calibrates. It's like senses what type of motor it is. Does that make sense? So here's another tip, is you probably want to fully charge your battery before you first use it. And probably the first like 3 to 5 times you use it, you want to use most of the battery and then fully charge it again. I probably should have done this last night. You're probably better off doing this outdoors, ideally in a sort of warm room like 20°C or more, a little bit more. And this is probably one of the times where the battery is most likely to catch on fire, because it's just been shipped around the world and whatever. So you may want to do this outdoors, away from the bike. Yeah. This is about halfway, so this will probably take 3 or 4 hours to get to full. But I need to do my programming, so I'll have to use it a little bit before then.